let's jump into the stack basics. So we'll go into what a balancer plant is for, what do we even need it for. So we need to provide purified water to the stack. So essentially what we're doing is we're supporting the stack, we're providing purified water. So we need to take the tap water, purified, put it into the electrolyzer, and we provide cooling. We remove impurities. So even after we purify the water, later we are going to have impurities during the electrolysis process which the stack releases into the water. We need to remove that, fluoride, etc. We've got DC power, and also the balancer plant system, of course, handles safety. We've got our friends at Rockwell Automation, and of course that, you know, the automation part is what is going to take care mostly of safety. And we've got the stack here, so I won't spend too much time on this because Mr. Stephen B. Harrison is going to hold a talk this afternoon about the stack, but I'll just have to go into it a little bit just so we understand how the balancer plant comes in to support the stack. So a PEM stack works as follows. We've got water going in, we've got the membrane in between them. So we have water going in into the anode chamber. So this is the anode side, the anode is the positive side or the oxygen side, and the water goes through and it comes out. When we start to add the DC power and we reach the threshold voltage, which is 1.48 volts, once we reach the threshold voltage, something very interesting will start to happen. Electrolysis will start to happen. So when we add the DC power, then oxygen bubbles will start to appear on the anode side, and hydrogen bubbles will start to, hydrogen is going to start to evolve on the hydrogen side. So the oxygen evolution reaction, hydrogen evolution reaction, and on this side we are going to have hydrogen gas and also some water. So in fact, if we saw if the tube coming out from the industrial scale electrolyzer on the hydrogen side, we would see, and it was see-through, we would see gas, but we would also see liquid water. We would see liquid water, which we then later have to separate. So I'm just gonna see if I can play. There we go. So this is a PEM cell. We've got the anode side and the cathode side. This is the anode chamber, and we'll have the H2O come through. This is H2O. The hydrogen separates off. The electrons will fire off through the electrical connections, and the protons are going to come through our membrane, and the proton and the electron will join, and it will form hydrogen atom and an H2 molecule afterwards. So again, we've got the hydrogen, the electron whizzes off through the electrical connections. What is electrical power? Electrical current is the flow of electrons. So the electrons will flow through the electrical wires, and they'll connect on the cathode side with the proton, and the proton, because it's a proton exchange membrane, the proton will go through the membrane. So in short, that is how the stack works. So we've talked about the first one here. We also have hydrogen purification. So the other role that the balancer plant has is purifying the hydrogen, because the hydrogen, like we said, that comes out of the stack is not 100% pure hydrogen. We have to remove the water, because that is liquid water, but also we have to dry the gas. And then we also have to remove the oxygen. And then we also have purity monitoring downstream of all of that as well.